Test. All right. We rolling? Rolling. All right. In place of our normal MC, John Heckler, I have taken the helm of being MC tonight. Here at the API Security Meetup, we have a repeat speaker. We do have Dan Barahona. Yeah, Dan Barahona, talking to us about the market research his company has done and hopefully dabbling in PCI 4.0. The first regulation to call out APIs specifically, which is pretty nice. But yeah, I'm glad you all are here. Excited, even though the rain kind of kept some people down. But hopefully we'll have a good chat and learn some things and enjoy some pizza. I think we're going to have Phil come up and talk about Engage first, and then do any other shout outs, and then we'll start in.
All right, thank you. Well, welcome, everyone. You are at Engage Partners building. So we are Engage Partners. We are a purpose-based IT consulting company. Build, QA, deliver. We're great at all those things. All right. So that's enough about us. Dan Barahona, take it away.
All right.
If you want to just, all right. Kind of put that on your zipper there.
Does that work all right?
Yeah, that'll do it.
All right. Oh, this went to sleep. Hold on. All right, everybody. You hear me all right? Okay. I'm a two-time presenter. I just have like a special, it's like being 5 times on Saturday Night Live or something. It's a very small club. It's very elite. I should have a special green room or something. Well, it's a pleasure to be back in Cincinnati. I feel like those rock stars like, woo, Detroit. I love Cincinnati. I've always had a good time here at Cincinnati, so it's a pleasure to be here. Hometown here is San Francisco, so I missed the eclipse by one day. I was convinced it was today. And missed it by 24 hours. So anyways, looks like it's a good thing it was yesterday, actually, probably. So I'm going to talk to you about some research that we've done on the API security market, some interesting findings, and we'll talk about PCI. We'll talk about some other interesting things here as well. As always, definitely welcome questions as we go along, and feel free to fire them off. So my name's Dan Barahona. I'm the co-founder of API Sec University. I imagine most of you are familiar with it, but if you're not, here's a little bit about API Sec U. We launched this kind of as a total flyer 18 months ago. I worked for a company called APISec.ai. We do API security testing, and we had this idea like, hey, why don't we make a course and see what happens? So I teamed up with my buddy, Corey Ball, and he created this API pen testing course. I made the website, and after 3 months, we had 30,000 people registered for it. And it was just really absolutely exploded. A lot of people came to us and said, look, that course is great, but do you have anything a little easier, a little lighter weight? And so that was the inspiration for our second course, the API Security Fundamentals. It's only 90 minutes long, and it covers a lot of the basics and a lot of organization. In fact, Kroger now integrating these courses in-house as well. So we've been at it. We're at 18 months old now, and 75,000 people are enrolled. 75% of the Fortune 100 are enrolled. All our courses are free. There's no vendor pitch or infomercials or anything like that on it. So if you're not familiar with APISec U and you want to learn more about how to secure APIs, then check it out. Okay, so I'm going to give a little bit of background, and then we'll dive into the market study. So the market study itself, we surveyed our 75,000 members and asked them a bunch of questions, and so that's what we'll share with you here today. But kind of to set the stage, I kind of like to give these sort of foundational stats. So 83%. Does anybody know what 83% is? Nobody? Traffic on the internet, yes. 83% of the internet traffic is APIs. This is kind of an old stat from 2019 from Akamai. Some people tell me it's north of 90. Some people tell me, no, that's all wrong. Whatever, it's a big number, right? APIs are dominating how we build and run our applications. That is undisputed. Anyone know what number 1 is? You're number 1. There, this is number 1 right there. You saw it. Number 1 is where API attacks rank. according to Gartner. This is also an old stat. It has a future tense here. So in 2020, Gartner predicted that by 2022, API attacks would become the most frequent. And I don't think they've backed off from it. And I think you'll see here in a moment how very true it is. All right, 4%. Any guesses on what 4% is? That's probably a fair proxy. So 4% is, of all the testing that we do on APIs, what percent is security testing? All right, this is from Rapid API and their state of API. So we do a whole lot of happy path testing, right? Does this thing work? Does it, does the function, does it perform as expected, right? We do all that positive testing. Way down at 4% security testing, right? I really don't need to show this slide to this audience, but this is the kind of like why do attackers love APIs slide, right? And you just look at it. It's just sitting here at this intersection point, right, of all our UIs, our front ends, functionality we expose to our customers in the outside world, to all that back end stuff, right? And this is both a blessing and a curse, right? Because this is so clean and simple, and it enables all that wonderful 83% of the internet to work. But if there are any flaws in here, right, they're also showing up right there in the API, right? If there are any config problems, logic flaws, right, things we've not tested, unanticipated use of our APIs, that's all showing up here as well. And if you think about kind of what we do historically, right, you got the front end that talks to the API, that talks to the back end. And historically, we've devoted a lot of our attention to the front end and locking it down, right? It's where we authenticate users. It's where we filter data, right? We show you certain features and not other features depending on your permissions and your user type. We do web app scanning, we do all that thing, and here's what happens, right? And I imagine most of you already know this, but attackers are gonna go to your website, they're gonna play around with everything on it, and they're gonna find the APIs that sit behind it, right? And then they're gonna go straight to the API itself, right? And this is what happens, right? And when they get to the API, they find often apps that are, or APIs that are over permissioned, right? They have access to more data than you reveal in the UI, functionality that you don't want users to use, logic flaws that aren't accessible in the UI, and so forth. And that's why attackers love APIs. Now, last time I was here, I showed a whole bunch of stories, and so I can't go back to the well and repeat those same stories, right? I could do Coinbase for the 500th time. It's a really incredible story, and if you haven't heard the Coinbase story, come talk to me over beers. But this is a new one. Here's Trello. So it's January 16th. This is the posting on the dark web of 15 million Trello accounts. How did this happen, right? So if I want to invite you to my Trello board, right, there's a feature, right? Type your email address, and some back-end process will fire up and send you an invite, right? Well, it turns out that back-end process is powered by an API, right? And it takes as an input an email address, right? So if you feed this endpoint an email address, it will check if that's a valid user, and if it is, it will return, is it valid, and what do we know about that user? All their profile information. And guess what? That API was exposed to the internet with no credentials, no security, no password, no nothing, right? No one ever expected, I'm sure no developer ever expected someone to find it or use it or do anything with it, but they did. So they found this API and they said, oh, this is cool. I can send any email into this endpoint and it will reply with all this information about them if they are a valid Trello user. So what do? They went on the dark web. They grabbed 500 million email addresses from harvested breaches and all that kind of stuff, right? And they fired off 500 million requests at this API, right? 15 million matched, right? And now what they were able to do is they took this public information about these Trello users. And by the way, your public profile on Trello is kind of a anonymous thing, right? So I'm told. But now you're connecting your public profile to your personal email address, which is pretty identifiable, right? Like my email equals me, right? And especially if you combine it with other stuff from the dark web, you've got a pretty good picture of me. And so they found 15 million requests or 15 million matches. They put it up for sale. This is the posting on the dark web selling 15 million Trello accounts, right? All because of this API. So what stands out to me for this is the 500 million, right? Like their API got hit 500 million times without getting noticed, blocked, something changed, right? And if you read the articles, Trello say like we had WAF in place, we were doing rate limiting, we were doing detection and you name it, right? But they still got 500 million requests, right? And so here's the deal. Attackers know you've got WAF, right? And they're gonna rotate their IP addresses, they're gonna use proxies, they're gonna not have, cookies or whatever they can do to avoid detection. They probably ratcheted up their requests until they got blocked and then dialed it back just a little bit below that threshold. Like, all right, we can't do 10,000 an hour, let's do 9,000 an hour, right? And that's what they do. And to get 500 million requests, they must have been doing this for months at a time, right? Without being detected, right? So what I conclude from that is they didn't need better rate limiting, right? Because at some point, you could ratchet that down where it's actually impacting real business. What they ended up doing to resolve this thing was not improve detection or anything like that. They actually had to lock the door on that API, right? Until then, the API was wide open. Anyone could use it anonymously without any credentials. But by locking the door and saying, you have to authenticate to use this API, right? Now they could attribute all that traffic to an identified user. It doesn't matter what IP address they use or how many they do, right? Now they can actually identify who's sending this. And even if they had a bunch of fake accounts, there aren't enough fake accounts for that to go unnoticed, right? They would definitely notice 500 million new accounts, right? Guarantee that's going to get noticed. Okay. Oh, I was going to do some fun audience participation here. So we'll try to make this work. Okay. So take out your phones. Hopefully that's big enough for folks online, or you could just type it apisecu.typeforum.com/trivia1. And it's just one question. What's the leading cause of API breaches, right? So, Michael, you're not allowed to answer that one. But everybody get a picture? All right, okay, cool. We'll come back to that later. All right, so we did run this survey. We asked 75,000 people what their thoughts were on various different things. And all right, we're just going to pop through a bunch of these survey results. So, all right, what were your number one breach concerns? Nothing too really shocking here. Data exposure, number one. Account takeover, number two. Fraudulent transactions, hacktivism. Lots of things written in as well, right? But that's what we found on breach concerns. What vulnerabilities have people experienced? This is kind of interesting. So number one we found here was broken authorization, right? That happens to be OWASP number one, right? Number two, missing or weak authentication. OWASP number two, right? Number three, lack of input validation, okay? That's kind of like SSRF. That's OWASP number 6, I think. 6 or 7. Business logic flaw right there as well. So that's kind of interesting, right? So people are recognizing that it's not just like your classic injections and cross-site scripting and that kind of thing, but it's actually exploiting unique features of your logic, right? And we see lots and lots of examples of that. Lack of rate limiting, apparently. 39%, quite common there. Injections, I don't know. I love that one, 18%. Don't know what kind of, they know they've had something, but they don't know what it is. All right, so we asked them, what are your biggest challenges with APIs, right? 2 of them came in over 50%. Number one, skills, right? And that just seems to be like pretty pervasive in cybersecurity in general. I think it's extra true in APIs. I think if we had launched WAF University, no one would have shown up. API Security University, 75,000, right? There's clearly a gap, right? There's a knowledge gap. There's a need to understand APIs and how they're being breached. So the skills gap, very interesting. Pre-production testing, right? Remember that 4%? So this is kind of validating, right? That at least we know that's a problem, right? But it's still a problem, right? And we got to do something about it. But 55%. Runtime protection, 45%. So basically, what can we do in real time to protect our APIs better? Visibility, so do we even know what APIs we've got? That's probably the number one question that I get asked is how do we do discovery? For which there is no simple answer. I think people will want like, here, just do this and you've got all your APIs. It never works out like that, right? So if you're going for 100% visibility, you could spend an awful lot of time and maybe never get there. And at some point, it probably begs a question like, when do you start protecting the APIs that you do know, right? Because I've seen people just get wrapped up in, we just got to discover. And meanwhile, like, you know what your mobile app is doing and you know what your web app is doing and your core business. Why not focus on those and get them secured? What kind of things are people using? Not too shocking here. WAF is number one. Manual testing, right there. So what's that? Pen testing, probably, right? Annual pen test or something like that. Lots of gateways. Automated testing is a lot lower than manual. Runtime threat detection, so detecting threats in real time, only 22%. Marketplace, sorry man, only 9%. Probably should be higher than that, don't you think? Yeah. So I don't know what you conclude from all this. The biggest thing we're using is WAF, and it's also the thing that's not protecting us from 500 million requests and the like. So interesting there. Okay, we asked questions about inventory completeness, and this is, you can read this all kinds of different ways, right? You could say only 25% of people think they have a complete inventory, right? You might say 25 and 37, what's that? 62%? Or two-thirds, close to two-thirds, have most of their APIs understood, right? Or you might say 75% don't have a good understanding of all their APIs. None, 16%, some 22%. Net is, it's kind of an elusive target, right? Like getting to 100% is distracting, frankly, right? I've seen people just devote all their energies into getting to 100% and don't devote energies into protecting, right? Actually, securing the things that are right in front of them. And we'll talk later about some of the real world breaches and what's actually causing a lot of the flaws. But yeah, go ahead, Robert.
Was there a follow-up question on the all to say, are you a startup that only has maybe 5 APIs, or are you an enterprise that has thousands?
Yeah, we did capture demographic data, right? So we were able to see like 0 to 100, 100 to 1,000. The interesting thing, I don't know about that specific question, but the worst performing demographic was the mid-size, was the 100 to 1,000, which was sort of surprising, right? So I would have thought it had been enterprise, right? Where it's like, who the heck knows how many we got, right? It's an unknowable number, right?
The worst performance on this or overall?
In general.
Okay.
It may have been on this as well, right?
Gotcha.
I think for startups, there aren't that many, right? It should be easy. It should be easy, right? And I think at the higher end, maybe there's a confidence that we've got it, and we've got tools and technologies and people focused on it. And in that mid tier, maybe they're just not quite there yet.
Also,
Go.
I mean, at the mid tier, you're in the place where you're doing a lot, but you don't have specialized teams.
Exactly.
Right?
Exactly.
So enterprise, you have the size where you can specialize, and you can say, all right, we got a team just focused on APIs. But in midsize, you're just doing what you can, and it's like, oh yeah, Bill over there knows a lot about APIs. Let's go talk to him, right?
Yeah, exactly. I remember talking to you a year ago about coming up with an inventory, and step one was, who's the one guy that knows everything?
Yeah.
Right? And then you realize there's more to it than that. Yeah, I think you're right. Like mid-sized companies, it's maybe they're in that in-between of maturity, right? It's not so small that you just got it. It's like there's only 5 of them. It's no big deal. Or you're so big where you have teams of people focused on it. So now, Robert, I'd actually be interested to run that particular slice on this data. All right. How good is our documentation? Megan's already laughing here. Let's see. All right, who thinks they got good documentation? 34%. They're lying. They probably are lying. You know, maybe it's delusion. Maybe it's delusion. They think they do. They just know that they don't know they don't.
There's no indication of time here. High quality, up to date.
Fair. It was high quality 3 years ago, right? It was high quality when we launched it, but now who the heck knows? Fair. We should add that question next year, for sure. No documentation, 9%. I'm sure that's not true either, right? I'm sure it's probably higher than that. Only the external, a few of them, partially, but like nothing is really dominant here, right? So it's kind of a smattering of everything. I think the reality is APIs still aren't documented enough, right? And it kind of confuses me, because what's the point of having APIs if you don't document them? Isn't the whole point to like enable reuse? I think we were talking about like people building duplicate APIs, right? Does that happen all the time? Yeah, go ahead, Megan.
Why do we think that there is such a lacking in API documentation?
I don't know. Do you have any theories? The question, I'll try to repeat for the stream. Why do we have a lack of documentation? Yeah.
We barely document our business processes, let alone any technical documentation.
We don't document our business. Well, and I think let me throw something out and see what you think. Like some organizations treat APIs as product, and some treat it as byproduct, right? So if you treat it as a product, is you more likely to actually do the manual, the documentation? Yeah.
Just to add, so I've spoken at conferences, had rooms of a couple hundred plus people. I ask, who here likes doing documentation? One or two hands go up in the entire room.
One of those is Robert.
There's usually one or two in every crowd, but they are like drops of water in the desert.
Yeah, no, who likes to do it, right? And does it mean you have to do it by hand, right? Like, you know, correct me if I'm wrong, but like you can auto-generate some of this stuff out of, you know, you're saying no, I'm sure there are limitations.
No, you can do it, I just don't recommend it for APIs. I feel that if you're doing design first, which is a good practice, you should document it before you ever go write the code, because you have the feedback loops to know that your API is solving the business problem and your stakeholders are happy.
Sure.
Therefore, your documentation is highest quality. But yes, a lot of people generate the code or the documentation itself.
Yeah. Net, it's not where it needs to be, right? And we do see a delta between like how people approach APIs. Like, is it a core thing? Do we treat it as a product, or is it just that thing that shows up along the way? So, well, these will be interesting to survey next year to see if any of these numbers change. All right, what best describes your testing approach? We do automated testing every release. Okay. Personally, even though we said security in this title, I think they're thinking not just security, right? We automate functional testing. Very, very few are automating security testing. That's just a fact. Manual testing, only major releases, it's maybe believable at 29%. If major releases once a year, something like that. Annual pen test, 22%. The thing that's interesting about the annual 22% is how often are you releasing code? It's definitely not once a year, right? So they're kind of admitting like that's a lot of code that's going out untested, at least security tested. Bug bounty, 9%. I'm curious, like, what's the general feeling about bug bounty in this room? Any opinions, strong opinions? Yes, no?
I mean, I'm a former Bug Crowd ambassador, so I'm a big believer in it. You know, it's definitely one of those things that not every organization has or is ready to stand up a bug bounty hunting program.
Yeah.
So, in particularly smaller organizations, it can be, I think, a big challenge to institute a proper program or engage with, you know, a big entity like a HackerOne.
Sure.
Or
Bug Crowd.
or something like that. But you know, one thing that people ask me about a lot of times are people trying to break into information security, and it's one of the paths I recommend is, you know, look at bug bounty hunting. You're not going to get rich doing it, but you have professional experience that you can talk about on your resume, and that's what's going to differentiate you from, you know, all the candidates that don't have experience or are trying to break in and they've got a fancy
certs.
Yeah, well, let me ask you a question. If you're a bug bounty hunter, right, you only get paid if you find something, right? So does that create a disincentive to go find the really hard things that there's a good chance you won't find, right? And it creates an incentive to go find the kind of the lower hanging fruit?
Because the harder ones usually pay more.
Yeah.
Yeah, but if you don't find it, you got nothing out of all that work, right?
But there are a lot of bug bounty hunters, like they started and they, like, oh, here's stack trace, stack trace, stack
Right.
trace. But then they started digging in and like getting better at it and finding stuff.
Okay.
I found the people in that community tend to be, pretty motivated
They
to
like the puzzle. They don't like the reward's there, but they like the puzzle and the challenge.
All right, very good.
It's more of
All
a
right.
passion and a hobby for them than anything.
All right, let's see what we got. Shift left. Oh, go ahead.
Go back, please. I'm curious on the automated testing. I wonder what percentage of that is just some kind of static analysis of the code?
Yeah. Yeah, I think that's exactly what it is, static analysis, right? They're doing some sort of test. It's maybe it's even DAST, right? They're running some injections and cross-site, kind of like low-hanging fruit type scenarios. But I think that's it. I think that's exactly it. All right, we asked the shift left versus shield right question. And of course, this is not really an either or, right? But we just were trying to get a vibe from people on where do they want to find their security vulnerabilities. So kind of not too surprising, right? The vast majority of people want to move it left. They want to find flaws before they make it live into production. So kind of, matched what we expected. And so, all right, let me shift gears here a little bit. So that's a bunch of survey results, and I'll show you a link at the end if you want to get the full report with all the details. One of the things we did in the report as well is we analyzed breaches, right? These were published, high-profile, in the news breaches of APIs. Every one of these is an API breach, right? And a few things stood out just from the list, which is it's a great big long list, right? It's not just little companies that don't have sophisticated organizations and the best technology, but some pretty sizable organizations in here. And the volume of records, right? 10 million records, 100 million records, close to 1 billion records. So, APIs are the cause of some pretty heavy-duty breaches. So what we then did was we tried to sort of assign or allocate each one of these breaches to some root cause or some attack vector, and see if there were any patterns that emerged. And this is what the data looked like. So right at the top, rate limiting, right? OWASP number 4. Almost 70% of those breaches involve some kind of rate limit flaw, right? And that's basically judged on if 1 million records got harvested, your rate limiting didn't stop it, right? It didn't prevent it from happening. And you might conclude from that your number one problem to solve is rate limiting. We got to improve rate limiting, right? But I think it's the wrong conclusion, right? It's the wrong conclusion because rate limiting is not the problem. The problem is you have APIs that are revealing something valuable, something worth stealing, right? If there was nothing worth stealing, you wouldn't try 500 million times or even 50 times. So, and frankly, I think it kind of reveals the limitations of rate limiting, right? If almost 70% of the breaches involved it, it's just saying like, look, this is your last line of defense, and it's not really gonna be able to protect you from all of these types of attacks, especially when attackers know that's what you're doing. So then what is the real root cause? And here's what was super interesting, was 90% of those breaches were the result of 3 of these elements, right? And it happened to map exactly to OWASP 1, 2, and 3, right? So OWASP 1, broken authorization, right? Can user A access user B's data? That's what we're talking about here, right? That's number 1 for a reason, and it has been since they launched the OWASP. Number 2, broken auth. Okay, so this is defined as like weak or poor authentication, and like, short password requirement, no CAPTCHA, credential stuffing. But that's not, we never ever see that, right, in any of those breaches. The weak authentication was no authentication, right? The API was just left with the door wide open. That's what we see all the time. And then number 3, excess data exposure, right? Is the API returning something of value, right? So probably some combination of those 3 is at play in 90% of the breaches, 90%, right? So we talk a lot about like shadow and rogue and leaked keys and all these things, right? But if you look at all those breaches, very, very few of them were that, right? And it doesn't mean you shouldn't, you shouldn't worry about leaking keys or not finding all your shadow and rogue APIs. But if you can address OAuth 1, 2, and 3, you've radically improved your API security posture. And this is the kind of thing that we present to a lot of organizations, to their dev teams, the people creating and building the APIs. And sometimes I've done workshops for organizations where at the end of it, they'll say, I already know some code I got to go fix, right? And this is, maybe I was over dumbing it down, right? But it's like, listen, if you can tackle these 3 things, right, you've really made a dent in the security of your APIs. And it's the kind of thing that's actually often not that hard to implement, right? Adding a rule or 2 into the code for authorization, making sure the APIs aren't left unlocked. Okay, so the major findings of the report, I just covered that. Skills, still number 1, strong preference for shift left, and the big testing gap. So I'm going to pivot into PCI here in a little bit, but before I do, I wanted to talk a little bit about this API security lifecycle. Right, so we started to look at those three items, and we said, well, how are organizations going to improve their security against these 3 things, right? Let alone 4 through 10. And so we looked at this simplified API lifecycle, and we wanted to see, like, what can you do at the various different stages in terms of security, right? And where in this lifecycle can we address authorization, authentication, data exposure, and the like. So, all right, let's say you start with you need a new API, right? So we all sit around the whiteboard and we come up with the requirements and how it should work, and we draft that all up, and hopefully security is in the room, right? Talking about how it should work, what we should be worried about. So you're starting to introduce security into the design phase. Great. Then you move into development, right? So now we're coding the application itself, right? And you're doing all the things that you already do. Code reviews, static analysis, SCA, looking for vulnerable libraries, all these kinds of things. Now, that's all good, and you should do it, but none of those breaches was a vulnerable library or anything like that, right? These were logic flaws, right? So then you move into testing. And what have you got in testing? You've got your legacy DAST kind of tools that are frankly looking for kind of basic flaws, right? Injection, fuzzing, cross-site scripting, right? None of those breaches was an injection attack, not one of them, right? Those are pretty easy to detect and to defend against. So, and then what are you left with? Pen testing or bug bounty, right? Manual testing. And so we believe there's a big gap here between development and deployment in terms of how we test APIs to look for vulnerabilities. Because after that, now you're live, right? Your API is live, it's in production, and what have you got? You got your gateway, which is okay. It can do some authentication, some traffic filtering, and that kind of thing. And you've got your WAF, right? Which is okay, but it's not going to protect against everything. Okay, so if you buy that there's a security testing gap, then the question is, where on this life cycle can you actually find these flaws, right? And it turns out that in runtime is a very difficult time to find API security flaws, right? If you want to find an authorization flaw, like can Dan access Michael's records, right? That's really hard to do in runtime, right? Because it looks like completely legitimate traffic. You're gonna have to do some weird baselining and statistical analysis and all that kind of thing. Whereas in testing, the test simply looks like log in as Dan, try to access Michael's records, right? Run these simulations, run all these different combinations. Same thing for authentication. If you want to find unlocked doors, turn the knob on every single API you got and see which ones work, right? For data exposure, query every endpoint and look at the data that comes back and analyze it. Is there something sensitive? Is there something valuable? Are we returning too much data for the application here, right? So this is just kind of reinforcing the need for more consistent, continuous automated testing. So let me let me move on from this. I think we covered this last time. I'm going to switch over to our PCI deck here in a second. But one thing I just wanted to share with you is we don't just do courses at API Sec University. We actually do conferences, we do webinars, we do workshops, and now we're actually releasing free utilities. Right? So what this is here, we call it API Sec Scan for CI/CD. So you can actually deploy this right in your GitHub environment. And it will take your API spec, it will generate tests, it will run the test all within GitHub and return the results right back to you. So it's a new technology we just launched, and if you're interested in it, please come check it out. We'd love to get your feedback on it. We are, before I move to the other deck, we're launching our own conference, and I invite everyone here to be part of it. It's all virtual, so you can join from anywhere. It's on May 22nd. It's no cost to sign up. We've got actually over 4,000 people are registered for this already, which is really remarkable. I don't know, we've got about 30 speakers or so. So if you want to learn a lot more about API security, please come check out APISecCon. And this is my slide with the report, right? So if you want to download the report, there is the QR code and the link. All right, so that's our survey. So let me pop over to PCI compliance.
Quick question about that lifecycle slide.
Yeah.
Is that a slide that you and your team came up with?
Yeah.
Why wasn't some of specifically the authorization, you got it being picked up during testing, but you got code reviews also under development. I would think there's an opportunity to pick up some of those vulnerabilities under the code reviews portion.
Somebody really wants to answer your question or add.
I don't want to hear his answer.
I kind of do, because you're probably both smarter than me on this.
Somebody that knows something.
Well, then you're looking at the wrong guy if you're looking up here.
So a lot of people do not test the authorizations because one, the identity platform that they're using, the pings, the octas, whatever, don't allow a bunch of anonymous accounts, or their security team doesn't want a bunch of anonymous accounts for reasons. There's not a way to generate anonymous users with accurate data to go through the flow and then destroy them so you can test all the permutations. They don't document the permutations or the authorization matrix, so they have no idea what to test in those scenarios.
Yeah.
And a lot of times people don't even comprehend the authorization checks that they should be doing across all the stats. They're still very much RBAC, I have group, you have access. It's not, I have group, you are in the right context, you do have access to this entity, and they don't do ownership models. It's a lack of authorization and identity management, education. Somebody needs to create an identity sec just like API sec.
Yeah.
This shit is wild.
We one of the things we see a lot is permission drift as well, right? So we produce an RBAC map that basically says, look, for every role you got, what access do they have, right? Down to the endpoint level, right? So for every endpoint, who's got what. And one of the best things people like is if something changes, right? Like this role didn't have access yesterday to this endpoint and today it does, they want to know about it. And most of the time, that's not the kind of thing security teams even ever find out. So the main point of that is like these things change over time, right? And you may not know that someone's modified RBAC rules or permission sets and so forth. So look, I'll take Robert's expert feedback, but I'd just say like the main point of the slide is you should do it wherever you can, but earlier is better, right? And so, talk about authentication during the dev cycle, sure, by all means, right? Validate it during the testing cycle and make sure it's actually behaving as you expect it to, and then continue to monitor it, see if anything is deviating in production.
I don't think anyone would ever say that code review isn't valuable for catching things. Essentially anything. But there's a reason we have tests. There's a reason we have automated testing. Things like that.
Right, but that's definitely something that, depending on the degree, right, that could get caught. Either it's missing,
For sure.
or the checks that are being made aren't the checks
Or
that were
insufficient.
aren't the checks that were in the spec.
Mm-hmm.
Right? Because somewhere along the time, the developer built off of something. They didn't make this up themselves. So, but those are two checks that could get picked up during a code review.
Absolutely. And so there is definitely an awareness issue there, and I think that, it's important to highlight that.
Well, and then the question is, how much do you trust the spec, right? Like, are we just validating that the spec is right and we're listening to it, or are we sort of playing devil's advocate and we're going to try all these things, malicious attempts on the API, whether the spec permits it or not, right? That's sort of negative testing scenario.
Anybody that builds software knows that the story that you're building from is wrong, because users don't know what they want until they see it.
Yeah, well, there you go. Yeah, agreed. All right, let me pivot over to PCI here. I'll spare you the opening slides. Okay, so we just went through a major evolution in PCI. So we went from DSS 3.2.1 to 4.0, and 4.0 became mandatory as of 2 weeks ago, March 31. A lot is in 4.0. I read it. It's 360 pages long compared to 139 for the prior edition. If you were to Google or do a Control F and look for API in 3.2.1, there's not one single mention, right? And 3.2.1, I think it's like 6 years old, 7 years old, something like that. There's not been any major updates to DSS in a long, long time. And in 4.0, it's all over, right? And that's what I'm going to show you here in the coming slides. So APIs are very much on the radar for PCI now. This shows you the timeline, but the net is we are right there where you are now required to be compliant. I've had some people say, isn't that when the transition period starts? No, that's when it stops. That's when you have to be compliant. Not everyone, I think, realizes that. Okay, so all I did, I'm definitely not a PCI expert, but I just went through the whole thing with an eye of APIs and thought about, like, where does it talk about APIs or where are APIs relevant? Okay, so we'll go quickly through this. We've got whole courses and documents if you want to learn more. So 227 is pretty basic, admin console access. You have to encrypt all admin console access. And now it says, including via API, right? So apparently that wasn't in there before. It needed to be spelled out. So if you're accessing the admin console through an API, that needs to be encrypted. There you go. Section 6 is really where the meat of PCI requirements are. It's the secure creation of software and applications. You're going to see this term a lot, bespoke and custom software. They like that term a lot. It's a complicated word for saying code you wrote, right? 6.2, bespoke and custom software is developed securely, and 6.3, security vulnerabilities are identified. Okay, let's keep going. 6.2.1, secure software development. Bespoke and custom software are developed securely based on industry best practices in accordance with the DSS, incorporating consideration for information security issues during each stage of the software lifecycle. So embedding security throughout the software development, good practice, understand how sensitive data is handled by the app. All right, so it just doesn't say API in here, right? But frankly, wherever you see custom and bespoke software, that by definition includes your APIs, right? You're not going to exclude APIs from that, right? It's part of the envelope, right? So, all right, they're starting to talk a lot about this. Let's go to 6.2.2. This is pretty simple, developer training, of which, of course, API Security is a great source. So software development personnel are trained at least every 12 months on software security relevant to their job function, including secure software design and coding, and including if security testing tools are used, how to use those tools to detect vulnerabilities, right? So you don't have to just train them on like what's the best practice, you also have to train them on testing and vulnerability discovery capabilities as well. That's right in here. Sorry?
That's a lot more ethical hackers.
Yeah, you would think, right? All right, what do we got? Good practice here, pretty. Training should include, but is not limited to, blah, 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 blah. Techniques, methods for finding vulnerabilities in code. Processes to prevent reintroduction of previously found vulnerabilities. And how to automate security testing tools to detect software vulnerabilities, right? That one about finding reintroduced vulnerabilities is an interesting one, because I talk to a lot of folks where they do a pen test, they get a report, they fix these things, and then those vulnerabilities come back in, they never know about it, right? And this is where like this automated continuous testing concept is really important. Okay, 622. 623, software code review. Here we go. Bespoke and custom software is reviewed prior to being released to ensure that the code is developed according to secure coding guidelines. Code reviews look for both existing and emerging software vulnerabilities. And here we go. Good practice. Confirm that software securely uses external component functions, including libraries, frameworks, and APIs. Right, so, and then down here, check the application's behavior to detect logical vulnerabilities, right? So these are like little words that have huge implications, right? Like you need to think about the logic of your application. How can it be abused? How can it be misused, right? This is, you know, things that we see in the OWASP as well, but really, you know, you're not going to find this in a CVE or something. Like if you're just testing for CVEs, that you're never going to find your logical vulnerabilities. So pretty interesting one there. 624 is I call this the OWASP section. It's prevent common vulnerabilities. So the requirements is use engineering techniques and methods to prevent or mitigate common software attacks and related vulnerabilities in bespoke and custom software. Including but not limited to, this is really where it gets interesting, attacks on business logic, right? Including attempts to abuse or bypass app features and functionalities through manipulation of APIs, right? This is probably like the most important three lines of the whole thing, right? Other stuff, communication protocols, client-side function. This includes cross-site scripting, cross-site request forgery. Attacks on access control mechanisms, right? So how do people log in? And then under the purpose, detect or prevent common errors that result from vulnerability code as early as possible. Have formal engineering techniques and tools embedded in the development process to catch these errors early. This is also known as shifting left. So they're not saying you have to, but they're making it pretty clear. Like find vulnerabilities, find all these different kinds of things. Abuse of APIs, of authentication schemes, and do it as early as possible. Developers should be familiar with different types of vulnerabilities and their attack vectors. So that's 624, 631, vulnerability management. Software or security vulnerabilities are identified, pretty standard stuff, right? But down here at the bottom, vulnerabilities for bespoke and custom and third-party software are covered, right? And so, you know, just continuing the focus on vulnerabilities, software inventory, an inventory of bespoke and custom software and third-party software components is integrated to facilitate vulnerability and patch management, right? So know your APIs, know what your environment looks like. Vulnerabilities in third-party components, including libraries and APIs, can render those applications vulnerable to attacks. Right? So you're just seeing this like repeated focus on APIs throughout PCI. 641 and 642, I merged these two together. Basically, you have a choice here. You can either do annual vulnerability testing, or you can use like WAF, right? Some sort of inline enforcement. So for 1 year, you can do either or, and in 2025, you have to do inline. It's mandatory. And they basically say, like a WAF, basically is what they're saying. So what do they say? For public-facing web apps, new threats and vulnerabilities are addressed on an ongoing basis. These apps are primary targets for attackers. Poorly coded web apps are an easy path for attackers. Good practice, manual or automated vulnerability security assessment tools. Examples, web app firewalls, and the like. So you got a choice for a little while, and then you have to go to active protection. I'm not sure who would not have a WAF at this point. But yeah, go ahead, Robert.
So with number 2 over there, on the install automated detection of blocking, how long until the attackers do a business denial of service by overloading false reports to shut off all access?
Yeah, I mean, I don't know why they made this an either or. It seems like you really need to do both.
Well, but automated gives you a lot of red herrings and a lot of false positives, and if it's automatically blocking things that are fake,
Yeah.
potentially ruining business.
Yeah, I hear you. I think this is in there because you should be blocking what you can block, but that can become its own threat vector, right? So be smart about it, right? Don't implement blocking that can be abused and create its own denial of service on you. Yeah, yeah, yeah. All right, now we're out of 6. 7.0, I just kind of flagged this. It's all about logging, and so make sure your logging includes logs at the API level. Oh, sorry, that was 10.0. Oh, this is strong access controls. All right, this is all about RBAC, what we were just talking about, right? Make sure you're controlling who has access. 10 is logging and monitoring. And 11 is really kind of slightly bizarre, right? Security testing. And the only thing that I could really find in here is this one little comment: bespoke and custom software should be tested frequently. You know, of course, there's a lot more detail in section 6 that go into more specifics there, but there you go. You need to be testing your APIs and all of your software regularly. So that's PCI. I don't think there's much more in here that we haven't already touched on. I'll just throw this up and leave it. If you want to talk or chat or discuss any of this stuff more, there's my email address. Definitely invite you to be in touch. Check out API Security University. Hopefully you'll sign up for our conference in a month or so. Should be a whole lot of fun. I can't imagine what having 4,000 people on a WebEx is going to be like, but probably not going to be all 4,000. But I don't know. That's all I had today, so thanks for making me a two-time speaker, and I'm happy to field any questions or discussion.